Okay, I want to pick back up where I left off in class. We were working on this one in class. It looks like I might need to zoom out on this one for the other zero. So if I hit second calc, intersect, first curve, second curve, I'm going to guess over here and see if it'll find the answer. Oh, look, it says 1.732. So even though it's off the screen, it still gives me that answer there. So this is a good example of like using your calculator to do that problem in class. Okay, so you find the intersection button and then you give me the x values for each one of those. Okay, but the other thing I want to talk about before the next homework is, what do you think that this means? So it says find d squared y over dx squared. Well, that means find the second derivative. And with implicit, the second derivative is kind of a lot of work, in my opinion. So step one, I'm going to find the first derivative. So I'm going to do 2y dy dx plus 2 dy dx, because I'm taking the derivative of y also. And then this would be just 2 on this side, right? Because the derivative of 1 is 0. So write really small here, kids, because we got to do a lot. So this would be 2y plus 2. And if I divide it over, I would get dy over dx equals 2 over 2y plus 2. Or if I simplify that, that would be 1 over y plus 1, because all of those are divisible by 1. That is the first derivative. Now I want to take the second derivative, and this is the simple for the second derivative when you're using dy dx. So now I have to take the derivative of this. And how would I take the derivative of this? Hopefully you said the quotient rule. Isn't that exciting? So the quotient rule here would be the derivative of the top, which is just 0, times the bottom, which is y plus 1, minus the derivative of the bottom. And the derivative of y plus 1 is just 1. But what do I have to do when I take the derivative of y? I have to do dy dx all over the denominator squared, which is y plus 1 squared. So on the top here, 0 times this is just 0. So I just have negative dy over dx over y plus 1 squared. And you might think, well, that's all I can do. But you would be wrong, because we know that dy over dx equals 1 over y plus 1. So I can replace that. There's a negative there. So that would be negative 1 over y plus 1 over y plus 1 squared. And just like we've talked about, we don't want to leave a fraction in a fraction. So I'm just going to multiply the top and the bottom by y plus 1, because that would cancel this out. And I would be left with negative 1. And y plus 1 squared and y plus 1 is y plus 1 to the third. And that would be my second implicit derivative. So to recap, step 1, you take the derivative. Step 2, you take the second derivative. Step 3, everywhere there's a dy dx, you plug in what your first derivative was. Step 4, you simplify. So let's do another one. Given the curve x squared plus y squared equals 1, find the second derivative. So what's the first derivative? I would get 2x plus 2y dy dx, and the derivative of 1 is 0. So again, usually when they ask you to do a second derivative, it's not so bad. It's not as ugly as some of the other ones that we've done. I would subtract 2x over and divide by 2y. So I would get negative x over y. So it's usually not super ugly, but it's usually a fraction, which means when you do the second derivative, you have to do the quotient rule. Everywhere I take the derivative of y, I do dy dx. So the derivative of the top is negative 1 times y minus the derivative of the bottom. So, but that negative is going to throw me all off, right? So I'm going to change this to plus because I'm going to leave the x alone. And the derivative of y is dy dx all over the denominator squared, which is y squared. So, questions to that point. Now I'm going to plug in my derivative, which is negative x over y. So I get negative y plus x times negative x over y all over y squared. And every time we deal with fractions, we have to talk about this same issue of how do we simplify this? And you have two options. One option is you can get a common denominator on the top and then invert and multiply. My option that I like is I like just multiplying everything in the top by that denominator that I want to get rid of. And so see if this makes sense. Y times negative y is going to be negative y squared. But when I take y times this, it cancels it out. So that would be minus x squared. And then on the bottom, I get y cubed because y squared times y. This is one that I think is really crazy because this was my answer and I've done this before. And then when I look at the answer key, it's not the answer. And I'm like, what's happening? But let me show you. Could I take a negative out of this and then that would become x squared plus y squared all over y cubed? And you might say, why would you do that? Well, if I come up here, look at this. X squared plus y squared equals 1. So since x squared plus y squared equals 1, you can replace that in the problem. And that's what the answer key says, which I find to be crazy, but I just want to point that out. So now look at this one. Okay, let's hope my sound is still working because it made a funny noise. So this is from the 2008 AP exam. This is Form B. We can talk about what that is later. But this is a real question, and I just want you to see what it looks like. It says, consider the closed curve in the xy plane given by this. Show that the derivative equals this. So notice that they give you the derivative, and you have to make your work match this. And then it says, write an equation for the line tangent to the curve at the point. And then it says, find the coordinates of the 2 points where the curve is vertical. And is it possible for it to have a horizontal tangent? So here's what I want you to do on this. I want you to try this and see where you get. And then we'll see what happens on Monday. But definitely for sure on Monday, you're going to start working on homework 28. Most of this is just practicing your implicit. But if you look at the second page, there's going to be a little bit more stuff to do. And then there's a third page as well. And look, oh my gosh, it looks like the one that's over here. So work on this, and then I'll try to work it out for you on Monday.